This is a framework I learned about when I was a kid playing League of Legends, and it's become a cornerstone of my SoloQ philosophy. It goes something like this. You are one person out of 8 in the lobby. You're only a quarter of your team. Some games will be unwinnable. Some games will be unlosable. However, your opponent's team has 4 SoloQ randoms, whereas your team has 3 SoloQ randoms and you. So the rules for climbing are thus. If you are slightly better than the average player in your lobbies, and you put in enough games, you will climb. Of course, this makes a handful of assumptions, and I don't have time for all of them, but I do want to touch on one. This assumes that the randoms you're getting on your team are the same as the randoms that the opponents are getting on their team. Now, there are definitely some edge cases where this isn't the case, particularly in ELO brackets with fewer players, but 99% of the time, no, the matchmaking isn't programmed to screw over you specifically. That's just negativity bias. If you're interested in how I address any other assumptions that this makes, feel free to ask me some what ifs in the comments. Now, I want to talk about the second requirement for climbing, putting in enough games. If you've been around, you might recognize this as the law of large numbers. The top search on Google defines the law of large numbers as the statistical tendency towards a fixed ratio in the results when an experiment is repeated a large number of times. The idea is pretty simple. Flipping a coin 10 times and getting heads all 10 times is a lot more likely than flipping a coin a billion times and getting all heads. Given enough data points, bad luck will be met with good luck and you'll be left with the average. Now, I'm not a statistician. I almost failed stats in college. So I'm not going to show you a bunch of fancy equations that prove you have a 99% chance of getting X rank if you play 10,000 hours. But I am a computer scientist, so I wrote this little demo. If you aren't interested, feel free to click off the video now. I've talked about all the conceptual stuff I'm going to. Now I'm just going to have some fun with numbers. The simulation works like this. Let's say the average player has a skill level of 50, and then let's say the standard deviation is 10, so we end up with a bell curve that looks like this. Now you're a respectable player. Let's say your skill is 55. We're going to add up the skill level of 4 random samples from this bell chart, which will represent the enemy team, and then add up 3 random samples plus you, and that's your team. Splatoon is super volatile, and the better team does not always win, so instead of just comparing to see which number is higher, we're basically going to turn this into a pie chart and then spin a wheel to see who wins. Okay, so let's say you're a pretty casual player. You play 10 games a day, right? Okay, so today you had a 40% win rate. Next day, another 40% win rate, 20% win rate. We're getting really unlucky. 60% win rate. We have a good day there. 50% win rate, 30%, 70%, 50%, 40%. Seems like we're getting pretty unlucky. It's kind of a coin toss on whether or not we have a good day or a bad day. Um, but let's say we play, we're a super sweaty tryhard and we play like 50,000 games a day. You have a 50.6% win rate, 50.4% win rate, 50.6% win rate, 50.6% win rate, 50.7, 50.7, 50.8, 50.4, 50.1, 50.5. You get what I'm saying. If you play a lot of games, this randomness, this coin tossiness kind of goes away. So if you really want to climb and you think you're good enough, sometimes the problem is that you're just not playing enough games. And you just have a small enough sample size that bad luck is very much on the table. Um, I think this is helpful to keep in mind when you have a bad day, because it doesn't mean necessarily that you played bad. Sometimes it's just like you happen to get unlucky with the teammates you got. Or like, maybe in every one of these we had a better team, but like the spinning the wheel just ended up on a loss every time, you know? Splatoon's really volatile, and bad luck can absolutely affect your day-to-day performance. But if you get a lot of data, you'll see it's pretty consistently around a 50% win rate. And here we're never dropping below a 50% win rate. So if you put in enough hours, if you put in enough games, and you do deserve to climb, you will climb.